Good morning, grade 7. For today, we are going to discuss Quarter 3, Module 3, Inferring that Waves Carry Energy. Objectives: understand waves as carriers of energy. At the end of this module, you are expected to: number 1, label the basic parts of waves. 2, differentiate mechanical and electromagnetic waves. And 3, explain how waves carry energy from one place to another. What I know. Choose the letter of the best answer. Write the letter of your choice on your answer sheet. See pages 3 to 4 of Quarter 3, Module 3. What's in? In the previous module, you have learned about motion. Let's find out if you can still remember the different graphical interpretation of distance over time. Directions: read each description carefully and then draw its graphical interpretation. Number 1. Object is accelerating. Object is moving away from its starting position at an increasing speed. So, to draw a graphical interpretation for this, all we need to do is draw a curved line. So what does this curved line mean? As time increases, the distance traveled by the object also increases. So this means that the object is accelerating. Next, number 2, object is moving at a constant speed. Object is moving away from its starting position. So for this one, all we need to do is to draw a straight diagonal line. So what does the straight diagonal line mean? So it means as time increases, the distance traveled by the object also increases at a constant speed. So with this kind of graph, we are able to make predictions. Next, let's go to number 3. Object is accelerating. Object is returning to its starting position at a decreasing speed. So if the speed is decreasing, then we need to draw a curved line, but this time it's the other way around, like that. Okay? So what does this curved line mean? It means that the object is returning to its starting position, which is 0, and the speed is decreasing. Next, number 4. Object is moving at a constant speed. Object is returning back to its starting position. So, for number 4, we also draw a straight diagonal line, but this time, the speed is decreasing. So, we draw a diagonal line like this. So, what does this mean? So, as time increases, the distance goes back to its starting position. And then, for number 5, object is not moving or at rest. So, we are going to draw a straight diagonal line, a straight line, I mean. So, what does this straight line mean? It means that the object is not moving. It's at rest. Speed is 0. Okay, so here again are the answers for what's in. Next, what's new? We are going to read a short selection and then answer some questions later. So the title of the selection is Wavy Waves Adventures by Mary Ann B. Lagniton. Stephanie Shane is a very curious student. She always asks a lot of questions. Stephanie is also determined to be successful in her studies. She lives in Pugad, a remote island in the municipality of Hagonoy, Bulacan. Though living afar, she and her cousins still enjoy a 30-minute long boat ride just to get to their school every day. On their way, they like watching fallen leaves being swept away on the river as their boat moved to their route. In her thoughts, how do these leaves move on different direction, yet the water remains in its place? As part of their class discussion on that day, her science teacher explained leaves are carried away because of the waves. It's energy being transferred on the leaves that make them move. Her teacher also discussed the different types of waves such as mechanical and electromagnetic waves. She gained the knowledge she needed to understand how floating leaves on the water move away while the water remains in its place. Stephanie also recalled on their experiment that energy from mechanical waves can't be transferred without any medium, such as solid, liquid, or gas passing through it. Stephanie was very happy for the new learning she gained in her science class. She is really eager to explore new discoveries and learnings, especially by doing an experiment on her science class. Stephanie's curiosity about waves was answered by their lesson. Traveling back home, Stephanie exclaimed how wonderful waves are created as she touches the crest of the wave. She also has realized waves are beautifully created by God, and she continues to listen to the sound of the waves as she closed her eyes to feel it too. The waves that slightly hit their service boat seemed to be a beautiful scenery to all. It was indeed a great day. So let's answer the following guide questions. Number 1, describe the place where Stephanie Shane lives. So she lives in Pugad, a remote island in the town of Hagonoy, Bulacan. Next, number 2, identify the different medium needed in order to transfer energy in waves. So this medium are solid, liquid, and gas. And number 3, based on the story, identify what type of wave was described and the part of the wave that was mentioned. So the type of wave that was described is a water wave, and the part of the wave that was mentioned is crest. So, another activity is to be done. The title is Let's Make Waves. What happens when waves pass by? So, objectives. In this activity, you will observe and draw different types of waves and describe how they are produced. You will also describe the different types of waves. So, the materials that you need are a rope at least 5 meters long, a colored ribbon, a toy slinky or a magic spring, a basin filled with water, and a paper boat. Procedure A, what are transverse waves? So to answer this question, we need to do this. Straighten the rope and place it above a long table. Hold one end of the rope and vibrate it up and down. You would be able to observe a pulse. Draw 3 sketches of the rope showing the motion of the pulse at 3 subsequent instances. Draw an arrow to represent the direction of the pulse's motion. Okay, so if we are to do the activity, it would look something like this. So kapag yung ating rope ay binibrate natin or minove natin ng up and down, it will create a wave on the rope. Magkakaroon ng wave yung rope natin. At kung mapapansin nyo, ang direction ng wave natin ay papunta sa kanan. Papalayo doon sa source ng wave. So, ang source ng wave, itong kamay. So, noong minove natin yung rope ng up and down, nagkaroon ng wave, and then the wave moves away from the source. Palayo siya. So, yung bawat segments ng rope natin, ang kanyang motion ay up and down, whereas yung direction ng wave ay away from the source. Kaya, sabi dito sa nasa baba, the up and down motion of the rope is perpendicular to the direction of the wave. So, what does that mean? Yung wave motion natin ay papunta dito sa part na to. Tapos, yung atin namang particles ng ating rope, particles of the medium natin, ang movement naman niya ay up and down. Ganyan. So, perpendicular. So, let's answer the following questions. A1, what is the source of the wave pulse? So, paano nagkaroon ng wave doon sa rope? So, the answer for this, the source is the vibration of the hand. Next, A2, describe the motion of your hand as you create the pulse. A, up and down, or B, left and right. So the answer for this is letter A, up and down. A3, describe the motion of the pulse with respect to the source. A, the pulse moves towards the source. B, the pulse move away from the source. So, ang sagot dito ay letter B. So, di ba kanina doon sa ating previous slide, nakita ninyo na yung ating direction ng wave ay away from the source. Okay? So, next. You will now tag a specific part of the rope while making a series of pulses. So, when we say a periodic wave, it can be regarded as a series of pulses. One pulse follows another in regular succession. So, figure number 1 shows a periodic wave. So, ito ibig sabihin ng periodic, series of pulses. So, up, down, up, down. So, one pulse follows another in regular succession. So, ang tawag po muli dito ay periodic wave. So, tie one end of the rope on a rigid and fixed object, example given, heavy table, doorknob, etc. So, here in my example, I have tied the rope to a tree. So, these broken lines show the rope. If it's not disturbed or if it's not vibrated, it's just in a straight line. But when you vibrate it or when you move it, so when it moves, it will form a wave. Next, attach a colored ribbon on one part of the rope. You may use adhesive tape to fix the ribbon. Make a wave by continuously vibrating the end of the rope with quick up and down movements of your hand. Draw the waveform or the shape of the wave that you have created. So, in this picture, we have again the rope attached to a tree, and then we have attached a colored ribbon on one part of the rope, and we have secured it with a adhesive tape. Okay? So, ang gagawin lang daw, move the rope with a quick up and down movements. Tapos, observe daw natin kung ano yung nangyari sa ribbon na to. Okay? So, ask one of your relative to vibrate the rope while you observe the motion of the colored ribbon. Remember that the colored ribbon serves as a marker of a chosen segment of the rope. So, let's answer this question. A4. Does the wave transport the colored ribbon from its original position to the end of the rope? So, ang tanong, yung colored ribbon daw ba, noong minove natin yung ating wave ng up and down, na transfer from original position to the end of the rope, nalipat ba ng pwesto yung ribbon sa tingin nyo? So, ang sagot natin dito sa A4 ay no. So, remember na yung ating ribbon ay securely glued, nakadikit siya doon sa one part ng rope natin. Nilagyan natin ng adhesive tape. So, the answer is no for A4. A5. Describe the vibration of the colored ribbon. How does it move as wave pass by? Does it move in the same direction as the wave? So here we have two choices. Letter A, as the waves pass by, the colored ribbon moves up and down repetitively. It does not move in the same direction as the passing waves. Instead, it vibrates along the axis perpendicular to the direction of travel of the passing waves. Or letter B, as the waves pass by, the colored ribbon moves back and forth repetitively. It vibrates along the axis parallel to the direction of travel of the waves passing. So, ang answer natin dito ay letter A. So, di ba yung ating colored ribbon ay nag-move ng up and down, tapos ang kanyang vibration or direction ng waves niya ay perpendicular doon sa movement ng colored ribbon. So, para mas ma-explain pa natin yon, tingnan ulit natin yung ating illustration. So, here again is our illustration. So, when you vibrate the rope in a quick up and down movement, yung ating ribbon, tiyak na yan ay mag-move ng up and down, up and down. Tapos, paano daw ang movement or direction ng wave? So, yung wave natin ay away from the source. So remember na ang source natin ay ito. Siya yung nag-cause ng disturbance kaya nagkaroon ng wave yung ating rope. So yung wave natin ay away from the source. Tapos, yung bawat segments ng rope natin, ang movement naman po niya ay up and down. Kaya, ang tamang sagot doon ay perpendicular, hindi parallel. So, up and down ang movement ng colored ribbon, tapos yung ating direction ng wave with respect to the movement of the colored ribbon is perpendicular to it. So next, let's go to letter B. What are longitudinal waves? So procedure number 1, connect one end of a long table to a wall. Place a toy slinky toy on top of table. Attach one end of the slinky to the wall while you hold the other end. So are you familiar with a slinky? So a slinky is your magic spring. Do not lift the slinky. Ask one of your relative to vibrate the end of the toy slinky by doing a back and forth motion parallel to the length of the spring. Observe the waves along the slinky. Draw how the slinky spring looks like as you move it back and forth. So kung yung slinky spring ay imove natin back and forth, it would look something like this. So this is our spring attached to one end of a wall, and then here's the source of the vibration. So yung hand natin, ipupush yung slinky back and forth, back and forth. So ang mangyayari, pag pinush natin siya back and forth, ang movement ng energy ay away from the source. Papalayo doon sa source natin, which is the hand ng person. Tapos, makikita natin na yung movement ng spring natin produces parts ng spring na nakakompress or dikit-dikit. Tapos, meron din mga part na naka-expand or hiwa-hiwalay. Next, number 2, attach a colored ribbon on one part of the slinky spring. You may use an adhesive tape to fix the ribbon. Ask one of your relatives to vibrate the slinky spring back and forth while you observe the motion of the colored ribbon. Remember that the colored ribbon serves as a marker of a chosen segment of the slinky spring. So kagaya ng ginawa natin kanina dun sa rope, mag-a-attach din tayo ng colored ribbon doon sa ating slinky. So, it's like this. So, yung ating spring, okay, naka-attach pa rin siya sa isang end ng wall. Tapos, merong uling source of vibration. Ipupush yung slinky back and forth. Tapos, nandito yung colored ribbon. So, we have questions to answer. So, B1. Does the wave transport the colored ribbon from its original position to the end of the slinky? So, yung bang colored ribbon natin na nakadikit doon sa ating slinky, nalipat daw ba from its original position to the end of the slinky? Nalipat daw ba sa dulo ng slinky yung ating ribbon? So, the answer for this is no, hindi. Kasi di ba nakadikit nga siya doon sa slinky. So, paano siya mapupunta doon sa dulo? Okay, B2, describe the vibration of the colored ribbon. How does it move as wave pass by? So we have two choices. Letter A, as the waves pass by, the colored ribbon moves up and down repetitively. It does not move in the same direction as the passing waves. Instead, it vibrates along the axis perpendicular to the direction of travel of passing waves. B. As the waves pass by, the colored ribbon moves back and forth repetitively. It vibrates along the axis parallel to the direction of travel of the passing waves. So for B2, the answer is letter B. So yung ating colored ribbon, ang kanyang movement this time ay back and forth. Tapos, yung direction of waves natin ay parallel. Okay? So, yung ating ribbon, nag-vibrate parallel to the direction of travel of the passing waves. So, para mas maintindihan natin, let's look back at our illustration. So, here we have the slinky. So, pag binibrate natin yung slinky back and forth, the ribbon also moves back and forth. So, yun yung sagot natin, di ba? Back and forth ang movement. Tapos, yung direction ng waves naman natin ay parallel. So, ba't naging parallel? Ang direction ng colored ribbon ay back and forth, di ba? Yan, back and forth. Tapos, yung direction naman ng waves natin ay away from the source. So, kung makikita natin, yung ating dalawang lines na ginawa, okay, they are parallel to each other. So, next, procedure C, what are surface waves? So, kanina, letter A ay transverse waves, sa letter B, longitudinal waves. Ngayon naman punta tayo sa letter C, surface waves. So, place a basin filled with water on top of a level table. Wait until the water becomes still or motionless. Create a wave pulse by tapping the surface of the water with your index finger and observe the direction of travel of the wave pulse. Tap the surface of the water at regular intervals to create periodic waves. View the waves from above and draw the pattern that you see. In your drawing, mark the source of the disturbance. So, sa isang basin filled with water, kapag ito daw ay motionless na or hindi na gumagalaw, tap the water with your index finger and observe nyo daw yung direction ng travel ng wave pulse. So, papaano mag-travel ang wave pulse? Is it away from the source or towards the source? So, alin ba yung source natin dito? So, yung source natin ay yung finger. So, siya yung gumawa ng disturbance dun sa water kaya tayo nagkaroon ng wave. So next, number 2, wait for the water to become still before you place your paper boat on the surface. Create periodic waves and observe what happens to your paper boat. So, maglalagay tayo ng paper boat, tapos gagawa daw ng periodic waves doon sa basin of water. Next, let's answer this question, C1, C.1. Do the waves set the paper boat into motion? What is required to set an object into motion? Choose the correct letter. So letter A, yes, the waves move the paper boat. Energy is required to set an object into motion. Or letter B, no, the waves did not move the paper boat. There is no energy required to set the object into motion. So, ang sagot dito ay letter A. Yes. So, yung waves natin, siya yung nag-move sa ating paper boat. At para ma-move yung paper boat, energy is required. Next, C2. If you exert more energy in creating periodic waves by tapping the surface with greater strength, how does this affect the movement of the paper boat? So A, the wave carried more energy, causing the paper boat to vibrate strongly. Or B, the wave carried less energy, causing the paper boat to vibrate slowly. So, for this instance, if you exert more energy in creating periodic waves, then the answer would be letter A. So the wave carried more energy, causing the paper boat to vibrate strongly. So more energy means stronger vibrations. Effects of waves can be experienced every day. You can hear, see, and travel because of sound, light, and water waves. They are different, but they are all waves. So what exactly is a wave? So in this picture, we have examples of sources of sound waves, light waves, and water waves. So what is a wave? So a wave is a periodic disturbance that moves away from a source and carries energy with it. So wave is a disturbance that transfers energy from one place to another. Ocean waves can travel miles without moving itself. The water moves up and down as a disturbance that transfers energy. Waves can carry energy from one place to another. Substances do not move to another place. Waves may vibrate as energy moves through, but it does not go anywhere. So, himay-himayin natin yung ibig sabihin ng mga sentences na binasa natin. So, first one, ang wave daw is a periodic disturbance. So, kung walang disturbance, kung walang manggugulo, okay, ang ating mga matter here on Earth, solid, liquid, and gas, would be at rest or would be in equilibrium. But if there's a disturbance, then a wave will be formed. So, sa dagat, Kapag malakas ang ihip ng hangin, ang ating water, which is matter, an example of liquid, would form waves. So, yung waves natin, siya ay periodic disturbance at yung periodic disturbance natin moves away from a source. So, kung dito nang gagaling yung ihip ng hangin, yung ating wave ay papalayo doon sa source na yun. So, lagi niyong tatandaan na ang wave ay disturbance. Pangalawa, it moves away from a source. Papalayo siya sa source ng wave. At pangatlo, it carries energy with it. So, ano dala-dala nung ating wave? Energy. Kaya nga 'di ba kanina doon sa ating previous slide, kapag naglagay tayo ng paper boat sa ibabaw ng tubig, tapos nag-create tayo ng vibration sa tubig, our paper boat will move. So, bakit nag-move yung paper boat? Because the wave carries energy, and that energy enabled the paper boat to move. Okay? So, yan. So, ulit, ano ang wave? Periodic disturbance. Next, number 2, it moves away from a source. And number 3, it carries energy with it. So, energy lang ang kayang i-carry ng wave. Sabi dito sa ating binasa, substances do not move from one place to another. So, kahit na ang mga tubig sa dagat ay nagkakaroon ng waves, hindi naman nauubos yung tubig sa dagat, di ba? Because ang kine-carry lang ng ocean waves natin ay energy and not matter. Next, so let's discuss the different parts of your wave. Okay? So, if your matter is at rest, kung siya ay hindi na-disturb, ito yung kanyang position. Okay, ang tawag natin dito ay equilibrium. Now, kapag nagkaroon ng disturbance sa ating sample matter, mapa solid, liquid, or gas, it will form waves. Now, yung waves natin ay merong iba't ibang parts. So, we have the crest. Okay, yan. Tapos, we have the trough. This one. Then, we have the amplitude. Mula dito sa crest, papunta sa equilibrium. Pwede rin na mula dito sa trough, papunta dito sa equilibrium. That's also amplitude. And then we have wavelength, trough to trough or crest to crest. So what are the different parts of our wave? So number 1, we have the crest. Ito, ang crest natin. Lagyan natin na mark 1, 2, and 3. Next, we have the trough. Let's mark it. 1, 2, and 3. And then we have the amplitude. So, amplitude natin ay crest to equilibrium, crest to equilibrium, crest to equilibrium. Pwede rin na trough to equilibrium, trough to equilibrium, trough to equilibrium. So, we have 1, 2, 3, 4, 5, 6 amplitude. And then wavelength is from trough to trough. Pwede rin to, trough to trough. Pwede rin crest to crest, crest to crest. So, ilan yung ating wavelength? 1, 2, 3, 4. Okay? So, let's discuss the definitions of each part of a wave. So, number 1, wave crest. Wave crest is the highest part of your wave. Wave trough is the lowest part of your wave. Amplitude, the vertical distance between wave trough and wave crest. Wavelength is distance between two consecutive wave crests or two consecutive wave troughs. So, para mas malinaw, ito yon. So, yung crest natin, highest point or highest part of a wave. So, we have crest 1, 2, and then 3. So, dito sa drawing na to, we have 3 crests. Next, wave trough, the lowest part of a wave. So, ito yung trough natin, 1, 2, and 3. Next, amplitude, vertical distance between the wave trough and the wave crest. So, crest to equilibrium is amplitude. Crest to equilibrium, amplitude. Crest to equilibrium is amplitude. At amplitude din ang trough to equilibrium, trough to equilibrium. So, dito sa drawing na to, meron tayong 5 amplitude. 1, 2, 3, 4, 5, oh, hindi pala 5, 6. 6 amplitude. Okay? And then we have wavelength, distance between two consecutive wave crests. Dalawang magkasunod na crests, ito at saka ito, yung kahabaan na yan, ang tawag dyan ay wavelength. Tapos pwede ring two consecutive wave trough, ito hanggang dito ay wavelength. Tapos simula dito, papunta dito ay wavelength din. Simula dito, papunta dito ay wavelength din po. Okay, basta dalawang magkasunod na wave crest or dalawang magkasunod na wave trough, ang tawag natin doon ay wavelength. So next, let's discuss the two types of waves. First one is mechanical waves. So ano ba ang mechanical waves? So it is a wave that is a vibration in matter, transferring energy through a material. So para magkaroon ng mechanical waves, kailangan natin ng matter. So pwedeng solid, pwedeng liquid, or pwedeng gas. Tapos, yung energy natin transfers through a material. To create a mechanical wave, some initial energy has to be put into it. This is the energy that will then be transferred by the wave. So, the energy of a mechanical wave can travel only through matter. So, remember na ang mechanical wave ay kaya lang mag-travel kapag merong matter, kung merong solid, liquid, or gas. The matter through which the wave travels is called the medium. So, ang tawag natin doon sa material kung saan nagta-travel ang ating mechanical wave ay medium. At ang medium natin pwedeng solid, liquid, or gas as mentioned earlier. The particles of the medium just vibrate in place. As they vibrate, they pass the energy of the disturbance to the particles next to them, which pass the energy to the particles next to them, and so on. So particles of the medium don't actually travel along the wave. Only the energy of the wave travels through the medium. Okay? So, kapag halimbawa nagkaroon ng ocean waves, di ba yung ocean, hindi naman nauubos yung tubig sa ocean. Meron pa rin tubig sa ocean. Why? Kasi, yung particles of the medium, yung particles ng tubig, nagbabibrate in place. Tapos, yung energy na meron sila as they vibrate, ay tinatransfer lang nila doon sa particles na katabi nila. Kaya, ang nangyayari parang domino effect. Okay? Hanggang sa yung energy ay ma-transfer hanggang doon sa dulo, away from the source. So, for example, you could drop a stone in some water to create a water wave. So, the medium is water. Okay? So, ang water wave, para magkaroon tayo ng water wave, kailangan niya ng medium. So, ano medium ng water wave? So, it's water. Next, you could also speak loudly to create a sound wave. The medium of sound wave is air. So kapag tayo ay nagsalita, para yung boses natin ay makarating doon sa gusto nating makarinig nito, kailangan merong air. So ang medium ng sound wave ay air, hangin. So kung walang hangin dito sa Earth, wala tayong maririnig. Kaya in outer space, okay, dahil doon ay walang air, walang naririnig doon. Okay. Next, you might shake a slinky up and down to create a wave in the slinky. The medium is the solid material, the slinky itself. So, para magkaroon ng slinky wave, kailangan meron kang slinky. So, ang medium ng slinky wave ay slinky. E kapag rope wave naman, so para makagawa ka ng rope wave, kailangan mo ng rope. So, it simply means ang medium, yun yung kailangan mo para makagawa ng wave. Okay? So again, let's have a short recap. Kapag water waves, ang medium ng water waves ay water. Kapag namang sound waves, ang medium ng sound waves ay air. Ang slinky wave, ang medium niya ay slinky. Ang rope wave, ang medium niya ay rope. Okay? Kung wala yung mga medium na yan, walang mechanical waves. So let's take a look at transverse waves. So think of a rope that is tied to a doorknob. You apply one force to the rope by flicking it upward and an opposite force when you snap it back down. So this sends a wave through the rope. Both forces, the one that moves the rope up and the one that moves the rope down, are required to start a wave. So in a transverse wave, ang nangyayari, ang vibration ng ating medium ay up and down. Kagaya dito sa rope na to, pag minove natin yung rope ng up and down, of course, yung vibration din ng rope natin would be up and down. Tapos, ang movement ng energy natin ay away from the source. So, ito yung source natin, yung kamay, point A. Tapos, yung movement ng energy natin ay papunta sa point B. Okay? So, this is a transverse wave. Ang transverse wave, ang movement ng vibration ng kanyang medium at movement ng energy niya ay perpendicular to each other. Okay? Next. How about longitudinal waves? So, sa longitudinal waves, ang nangyari, the wave travels in the same direction as the disturbance. So, a longitudinal wave can be started in a spring by moving it forward and backward. So, the coils of the spring move forward and bunch up and then move backward and spread out. This forward and backward motion is the disturbance. Longitudinal waves are sometimes called as compressional waves because the bunch up area is known as a compression. So, dito naman sa longitudinal waves natin, ang movement naman ng particles ng ating medium, yung pinaka-spring natin or slinky ay back and forth. Or to the left, to the right, to the left, to the right. Ganun ang movement niya. Tapos, yung ating wave naman, ang direction niya ay away from the source. So, kung makikita ninyo, ang particles natin, ang particles ng medium natin ay to the left or right, or back and forth. Tapos yung direction ng wave natin ay away from the source. So, ang nangyari, vibration ng particles and direction of the wave are parallel to each other. Okay, parallel sila. So, ibig sabihin sa parallel, yung direction ng wave niya papunta dito, tapos yung kanya namang particles ng medium, ang vibration niya ay back and forth. Kaya parallel sila to each other. Compare natin siya sa transverse waves. Sa transverse waves, ang movement ng wave ay away from the source, pero yung particles naman ng medium niya, ang movement ay back and forth. Kaya sa transverse wave, perpendicular. Pero sa longitudinal waves, ito pinag-uusapan natin, ang movement ay parallel. Okay? So, yun ang pinagkaiba ng transverse sa longitudinal. Okay. So, here we have again a picture for longitudinal waves. So, makikita natin ang direction ng ating medium, back and forth or to the left and right. Tapos, meron tayong mga compression na nabubuo. Nagdidikit-dikit yung ating mga spring. Tapos, may mga part na hiwa-hiwalay sila. Tapos, ang direction ng wave ay away from the source. Papalayo sa source. Okay? Parallel sila sa each other. Next, how about surface waves? So kapag surface waves, forces are also required to start a wave in water. Think of a calm pool water. What happens if you apply a force to the water by dipping your finger into it? So the water rushes back after you remove your finger. The force of your finger and the force of the water rushing back sends waves across the pool. So take a look at this picture. So kapag nag-apply tayo ng force dito sa water, okay, tinap natin. So, ang mangyayari ay yung ating wave will move away from the source. So, di ba meron tayong makikitang circular waves sa tubig. Tapos, yung bilog na yon, di ba papalayo siya eh. Papalayo, palaki ng palaki yung bilog. Papalayo siya doon sa source ng vibration. So if you look at the unbroken swell waves in water, you will see that they are made up of a series of crests and troughs which move across the surface. So do you remember crest? It is the highest part of a wave, and troughs are the lowest part of your wave. If you watch a boat as ocean swells go by, you will see that it simply moves up and down. It is not pushed along. Only the energy travels. So, kapag nagkakaroon ng movement ang mga waves, ay energy lang po ang nagta-travel. So, the water only oscillates up and down. They vibrate in place. Kaya yung tubig sa dagat, di siya nauubos. Kasi, ang vibration niya in place. Tapos, tinatransfer lang niya yung energy niya sa susunod na particles Kaya, meron tayong nakikitang movement. So let's discuss the second type of wave, which is electromagnetic waves. So bago natin i-discuss further kung ano electromagnetic waves, balikan lang natin kanina yung mechanical waves. So pag sinabi nating mechanical waves, it needs a medium, okay, in order for energy to be transferred from one place to another. Para magkaroon ng mechanical wave, kailangan natin ng matter. So, pwedeng solid, liquid, or gas. Example ng mechanical wave, water wave. Ano kailangan para magkaroon ng water wave? Water. Next, sound wave. Ang sound wave ay mechanical wave. Ano kailangan ng sound wave? Kailangan niya ng air. Next, slinky wave. So, para magkaroon ng slinky wave, kailangan ng slinky. Rope wave. Para magkaroon ng rope wave, kailangan ng rope. So, pag sinabing mechanical waves, it needs a medium. Ngayon, pag sinabi naman nating electromagnetic waves, ano naman ito? So, let's read the following sentences. Light waves can obviously travel through empty space from the sun to earth. Light does not need a medium to travel through. Light can travel through some substances such as air, water, and glass, but it actually travels best through a vacuum. So, what is electromagnetic waves? Ang electromagnetic waves is a wave that does not need a medium to travel. Hindi na niya kailangan ng matter. Hindi na niya kailangan ng solid, liquid, or gas. So, electromagnetic waves, it travels best through a vacuum. Pag sinabi nating vacuum, through empty space. Isang example, the best example for this is light waves coming from the sun. So, yung mga light waves natin from the sun, it travels across empty space. From sun papunta sa earth, ano bang meron? Di ba wala? Vacuum, empty space. So, mas mabilis nakakapag-travel ang electromagnetic waves if they travel through a vacuum, as stated here. So, next, light is an electromagnetic wave. The energy is transmitted by vibration of electric and magnetic fields. There is a whole family of other electromagnetic waves. So the common names of each wave shown in the chart are radio waves, microwaves, infrared, visible, ultraviolet, X-rays, and gamma rays. So these are some examples of electromagnetic waves. So the picture that is shown here is an example of a light wave. So ang light wave natin, ang kanyang color ay white. But when it passes through a prism, the different wavelengths of white light is bent. Kaya nagkakaroon tayo ng rainbow colors. Okay, so we will discuss more about this in the next modules. So here is a diagram showing the different examples of electromagnetic waves. So, ang mga common name ng wave natin ay radio waves, microwaves, infrared, visible, ultraviolet, soft X-rays, hard X-rays, and gamma rays. Sa radio waves, ang sources natin ay AM radio, RF cavity, FM radio, and microwave oven. Sa microwaves naman, ang example natin dito ay radar. For infrared, we have people. For light bulb, this is an example of visible light. Ultraviolet, an example natin dito ay ultraviolet rays coming from the sun. For soft X-rays, we have the ULS. And then hard X-rays, X-ray machines, gamma rays, mga radioactive elements. Next, electromagnetic waves are emitted by a variety of electrical and electronic appliances that influence an integral part of our lives. So, radio waves are emitted by radios, microwaves are emitted by cell phones, and X-rays are emitted by X-ray machines. So let's go to the different activities. What's more, independent activity 1, word hunt. Encircle the 10 words that describe the characteristics and examples of mechanical waves and electromagnetic waves. Independent assessment 1, multiple choice. Encircle the correct answer. So number 1, waves that require medium to travel. 2, waves that travel through the vacuum of empty space. 3, what does the wave carry? 4. Which of the following is not a mechanical wave? And 5. You can't hear sounds in outer space because there is no... Okay, so encircle the letter of the correct answer. Next, independent activity 2. Check me. Identify the correct medium needed to transfer energy in waves. Put a check inside the box. Note there are two possible types of medium in each scenario. So, scenario 1, shock waves of an earthquake. So, saan ba siya pwede mag-travel? Air, sound, light, solid rocks, water. Next, thunder. Next, a surfer. And ripples spreading out in a pond. Independent assessment 2, matching type. Write the letter of the correct answer before each number. So, column A, it is sometimes called compressional wave. 2, waves that require substance are called. 3, what is the travel speed of light? 4. This is a rhythmic disturbance that carries through matter or space. 5. This is the highest point of a wave. 6. The lowest point. 7. Energy is transferred through vibration of air particles or particles of a solid through which the sound travels. Next, it is a sudden release of energy that has built up in rock as a result of the surrounding rock pushing and pulling on it. 9. This means across or crosswise. 10. It travels through empty space from the sun to earth. So, column B, these are your choices. Medium, waves, longitudinal waves, 300,000 kilometers per second. Sound waves, crest, earthquake, light waves, trough, and transverse. Independent activity 3, sentence completion. Complete each sentence below according to the hint letters provided. So number 1, E travels in waves. 2, the low points of a transverse wave are called. 3, the distance between any two troughs or peaks is called the. 4, L, waves move by pushing forward and pulling back. And 5, waves on the surface of water without barrier are examples of blank waves. Independent assessment 3, direction. Analyze the diagrams below. The diagrams show 3 different waves drawn to the same scale. So we have wave letter P, wave Q, and wave R. So, letter A, on wave P, label the position of a crest and a trough. So, nasan daw ang crest at nasan ang trough? On wave Q, draw an arrow to show the distance you would measure for the amplitude of a wave. So, dito sa Q, nasan yung amplitude? Nasan yung amplitude? Nasan? Yan. Tinuro ko na. And letter C, if these waves represent light waves, which one is the least bright? Okay. Next, 2. A cork is floating on a calm pond. Then someone drops a rock in the water so that a series of ripple waves move across the surface. Describe the movement of the cork as the waves reach it and go past. A. The cork move up and down. Or B. The cork move to the left and right. Next, what I have learned. Directions. Read the statement carefully and choose your answer inside the box. So, this paragraph summarizes the lesson in Module 3. So you need to complete the statements by choosing your answer from this box. Okay? Next, what I can do. So, match the description from column A with its corresponding application of waves in column B. Write the correct letter before each number. So, column A, it is used to see the internal part of the body. 2, it is used in scanning the womb. 3, it can be used to determine the depth of the sea. 4, it is used in drama stages since a couple of decades ago, mainly in places like cinemas. And 5, it is caused by a large-scale movement of the Earth's crust. So, ang choices nyo, earthquake, ultrasound, stage lightning, X-ray, and sonar. Assessment. Answer the questions on page 17 to 18 of Quarter 3, Module 3. Additional activity, performance test number 3.3A. So, Part A, building taxonomy. Now that you are equipped with a lot of knowledge about waves, list down at least one word that starts with each letter of the alphabet that is related to the discussion for today. For example, sa A, amplitude. So, related yan sa wave. So, susulat nyo dito sa bawat letter of the alphabet yung mga words related to waves. Okay? Next, performance task number 3.3b, concept map. Complete the following concept map below regarding waves. Some words are provided for your guide. So, wave has parts such as crest. It also has types such as mechanical and then it carries energy. Okay. So for quarter 3, module 3, these are the things that you need to have on your answer sheet. So number 1, what I know. 2, what's more. So sasagutan ang independent activities 1, 2, 3 at independent assessments 1, 2, 3. What I have learned, what I can do, assessment, and then additional activities. So your additional activities would be your performance tasks number 3.3, A and B. So if you're done, upload your answer sheets in PDF format in your Google Drive folder. Ang path natin, Science 7, Quarter 3, Module 3, or you may send them in JPEG format to my messenger. So thank you for attending our Science 7 online class. God bless you all.